Okay, so what we're doing here now is we're taking that same amount of water that we used in the previous problem, that's 5 grams of water, and we're going to add to that water 25 grams of magnesium chloride, and we want to find the temperature of freezing. Now, one of the first things we need to know is what is the formula for magnesium chloride. Magnesium is in the second column of the periodic table. It's one of the alkaline earth metals, and all alkaline earth metals have a 2+ charge. Now, chloride comes from chlorine. The only reason it has that IDE ending instead of an INE ending is that it's the anion of a binary compound. So monoatomic anions get an IDE ending. Almost any binary compound has an IDE ending. So chlorine is one of the halogens in column 17 or 7A of the periodic table. And all of those elements in a binary compound that are halogens will have a 1 negative charge. So to balance the formula, to have a charge-balanced formula for magnesium chloride, we need 2 of these chlorines in order to cancel out the 2+ charge here. And the result then is that we're going to have a formula of magnesium chloride and a sub 2 on the end. Well, the key thing we have here is the number of ions. That's what we're going to need for this particular problem. So that I, for our calculation, is 1, 2, 3 ions. 3 particles it breaks into. So I equals 3. To find the change in the temperature for freezing, we've got the formula is delta T, and this is for freezing, sub F equals I, that's the Van Hoff factor, times the specific heat, C, and then times the delta, what is that last term? No, K, wait a minute, no. Huh? No, it's K, right? And then, what's the last one? Molality, M or molality. Okay, I'm sorry. I'm trying to think of it, huh? Yeah, K sub F. It has to be the right freezing temperature constant, not the boiling temperature constant. Okay. So sometimes you see it written like this: I times K sub F times M for molality. Okay, either one of those 2 ways of writing the formula is perfectly okay. Well, this is the first thing we're trying to find. We've got to find this first before we can actually find the freezing temperature. This is the change in freezing temperature, and this change refers to the change from pure solvent freezing temp. Okay? Alright, so our equation then is, this is what we're going to find to start with, delta T sub F. I, we said, is 3. The freezing point constant for water is, what is it, 1.86? 1.86 joules per degree C per gram. And then the mass we have here is 5 grams. Okay, and to keep it all nice and neat, we're going to put everything over 1. Oh, y'all got it. That's right. You guys are using that. This is one way to do it. You guys are using that equation. I forgot that part of it. Okay, so you're using Kelvin then. So you still have 3 over 1. And so your equation is actually, well, your value is 1.86 joules over K times G? Let me look it up. Let me see here. Okay, Kelvin times, wait a minute. Kelvin, kilograms per mole. Oh, kilograms per mole. I got it. All right, because this has got to be molality. We've got to figure out the molality, so that's not right yet. Molality. Molality is moles solute over kilograms solvent. In our case, we have the solute is 0.25 grams of 0.25 grams of magnesium chloride, and this kilograms of solvent. The solvent is water, 5.00 grams of H2O. We need to convert this into moles, so we've got to find the molar mass. Magnesium and chlorine. Let's see, your periodic table has magnesium 24.30 and chlorine is 35.45. We have one of these and two of these, so 24.30 and 70.90 and 0, 12, 5, 9, 95.20 grams of magnesium chloride. Am I right? Am I wrong? I'm right. Okay, thank you. All right, so this will allow us to convert grams into moles in this fashion. We're going to put the grams on the bottom here to cancel out grams that are right there. 95.20 grams of magnesium chloride. And 1 mole goes on the top of magnesium chloride. Whoop. We can cancel grams and magnesium chloride. And to go from grams here of water to kilograms, we need this equality statement. 1,000 grams equals 1 kilogram. You want grams on the top to cancel the grams that are on the bottom. So 1,000 grams goes up here. 1 kilogram goes down here. Grams goes away. And we have moles of the solute over kilograms of the solvent. All we have to do is find an answer to find the molality. So a lot of you, I've been teaching you this way to do this calculation. This times this, then hit enter or equals, divided by this, hit enter or equals, then divided by that. If you have one of these Inspire calculators, there's another way to do this if you're interested in doing it that way. I'll show it to you here. Control divide, and I'll get an actual fraction. Okay, I don't know if you can see that. Maybe it'll show up. There we go. So I can put 0.25 over 5.00 and make just the actual fraction on the screen. Right arrow times and build another fraction, control divide. Put 1 over 95.20. Right arrow and times and control divide, and I can put 1 over, I'm sorry, it's supposed to be 1,000 over 1. So this fraction, this equation, if I can get it to show up well, looks pretty much like, without all the units of measurement, it looks like what's on your paper. Okay? Then all I have to do is hit enter to get the answer. You can choose to do it any way you want to, but I've been showing you one way to make it fast that works on every calculator. This method only works when you have one of the calculators that can do it this way. So since some of you are using the math departments or your own Inspire calculators, this might speed it up for you if you'd like to do it that way. Now I need only 2 significant digits because this number had only 2 significant digits. And so this number is moles of magnesium chloride over kilograms of water. And what you want to do is to keep your answer in those terms to fit it in this equation, because it's already broken out kilograms and moles. So what I want to do then is I want to round this off in this fashion. I want to say it's 0.53 moles per kilogram. Does that make sense? What I'm doing? Instead of writing 0.53 m, I'm going to write the answer in this fashion. because it plugs into this equation a lot easier. Is anybody confused by that? Do you understand what I want to do? Cancel units? I don't see anybody shaking their head up and down or going back and forth to tell me whether you understand or you don't understand. I need the feedback. Okay? I want you to understand. If I can't help, if I don't know, I don't want to give you quizzes to figure this stuff out every time. All right? That takes up class time we don't need to take up. All right. So by doing it that way, then we already have the units the way we want them to be able to cancel out. 0.53 moles per kilogram then has the units already nicely arranged. That goes away, and all we have to do is plug the numbers in to find the answer. And let's see, 3 times 1.86 times 0.53, and I get a change in temperature of 2.9574. I only need 2 digits, so I'm going to round off everything but the first 2, and I get 3.0 Kelvin, right? Okay, now, the original freezing temperature, listen, we're not quite done, because what we want in the question is what is the new freezing temperature with the addition of this amount of magnesium chloride. The original freezing temperature of water is 0 degrees C or 273.15 K. All right? The units of Kelvin, since this is, where's my number, my answer? Oh, since my units are in K for the change of temperature. Now listen carefully. I hope I don't want to leave anybody in the dust here. This is the change in temperature. The change means how much I go down. Since the size of a degree centigrade is the same size as a K, then I could also say 3K is equal to 3 degrees C. But that's only because it's change in temperature. It's not the real temperature, not the final temperature, but it's this. Everybody with me? So you could write your answer in 2 ways. It depends on what the question is asking. If the question is asking for Kelvin, then it's 273.15 minus 3.0. 273.15 K, because that's the freezing temperature of water, minus 3.0 K, and we get 270.15. We have to round off 1 digit, and so the freezing temperature of water with the addition of 0.25 grams of magnesium chloride is 270.2 Kelvin. Okay, that's one way to write the answer. Now, since this is a change in temperature value right here, this is 3 degrees or 3K change in temperature. It's also 3 degrees C change in temperature because the size of the temperature unit is the same. So the freezing temperature of water in centigrade or Celsius is 0.00 degrees C, and we could subtract 3.0 degrees C, and we get negative 3.0 degrees C. Okay, either answer is a reasonable answer given the wording of this question. I'm sorry, I had it off the screen where you couldn't see it. 270.2 K or negative 3.0 degrees C. Is everybody with me on that? Have I left anybody with their head spinning and doesn't quite get it? Everybody's cool? Say what?
Instead of doing like NGCL2, you put NGCL, but everything like is right for how we do it.
I'm so disappointed. No, I'm kidding. It happens. Okay, yeah. If I don't get to it in class, ask me after school, okay? The rule is you have to after school. All right? But yeah, of course.